It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Am I audible now? Now it is fine. Okay, great. So now let's start the session. So today, this is the second session in this. Today also, I brought the questions from network analysis, some digital ka questions and microprocessor ka questions from DRDO 2009 का पेपर. Okay, आज तो 2009 का पेपर लाया. And also ISRO 2014 पेपर से कुछ क्वेश्चंस लाया. Okay, let's start the session. So, if you want to go through my previous classes of free classes from our Unacademy app, that is the free special classes, just scan this QR code. You will be getting the access for all the classes. Okay, and right now HPCL का exam will be going to happen on this Sunday 12 p.m. So आप इसका HPCL का mock exam देके आपका preparation check करने के लिए 150 मिनट्स का एग्जाम है. 170 क्वेश्चंस मिलेगा आपको 24th July 12 p.m. डोंट मिस दिस. ठीक है. So the Lakshya batch is going to happen from tomorrow, that is 21st, and as you know, Sharma sir is going to start for you people what we call an aptitude. This is the right subject with the right teacher to start your preparation, guys. So you will be getting the aptitude in the best possible way. So that is going to start from tomorrow. You can start your GATE preparation with an Academy Plus subscription. You can use the code Shankar10. Okay. Right. So if you take an Academy subscription, you get the classes by the top educators, and you'll be getting the study note, test series, physical material, sorry, doubt solving sessions, you'll be getting it. If you need a physical notes, if you need one-to-one mentorship, you can go for Iconic subscription. Right, so this is the offer going on right now. If you take an Academy subscription, you will be getting 20% off on an Academy subscription. This is only for a few days. You can take this subscription. This is the final price. If you are aiming for 2023, you can just pay to 25,798. You will be getting the subscription. Right, so let's start the class. Let's start the problems. So the first question is ready for you. What happened? Just a moment. Ready? Okay, the first question is ready for you guys. You can give a try. Okay. So kindly give a try and tell me the answer. It's from microprocessors. So माइक्रोप्रोसेसर का क्वेश्चन तो है सो आपके पास एक इंटरफेसिंग का सर्क्यूट है विथ 8085 माइक्रोप्रोसेसर टू रीड 8-bit डाटा द अप्रोप्रिएट इंस्ट्रक्शन फॉर रीडिंग द डाटा सो आप ये 8-bit डाटा पढ़ने के लिए व्हाट इज द अप्रोप्रिएट इंस्ट्रक्शन टू डू दिस जॉब it's not a difficult question if you know the basics of the microprocessor you will be able to answer it just wait just think 16 bits are used in the addressing or 8 bits are used in the addressing if it is 16 bits memory mapped IO 8 bits IO mapped IO so accordingly you should check which instruction is to be used and which address is to be used Shivam option B diya I don't think it's wrong okay it's wrong so here first thing he used all the 16 bits for the addressing सारे 16 bits यूज किया तो आपको पता होना चाहिए 16 bits में ये होता है memory mapped IO मीन्स IO एंड मेमोरी दोनों एक ही तरफ से ट्रीट करते इफ दे यूज 8 बिट्स ओनली उस केस में ये होता है IO मैप्ड IO सो इफ इट इज ए IO मैप्ड IO इस केस में हम इन एंड आउट इंस्ट्रक्शंस यूज कर सकते हैं हियर यू कैन यूज MVI MOV LDA जैसा इंस्ट्रक्शंस यूज कर सकते हैं ठीक है कोई भी रजिस्टर का इंस्ट्रक्शन यूज कर सकते हैं ठीक है चलो भाई अभी तो 16 बिट्स तो यूज किया इसका मतलब ये तो मेमोरी मैप्ड IO सो ये सारे ये तो बबल कैंसिल होके ये सारे वंस होना चाहिए ये तो y2 को कनेक्ट किया तो 010 होना चाहिए सो इफ यू टेक द एड्रेस ये 15 14 13 12 ठीक है एंड सो ऑन A3 A2 A1 A0 ये सभी वंस होना चाहिए ओके A3 must be 1 A2 must be 0 A1 1 0 so this is A ये तो F and another F you will be getting it so the address is FFFF A so this is the where you have this 8-bit input data from here that is F A triple F ये से आप एड्रेस डाटा लेना चाहिए so you can take in FA no MBA FA no in FFFA no in is a 8-bit address load accumulator with the content of FFFA this is the right answer you need to load accumulator with the content of the memory location FFFA option D is the right answer okay So many people not able to answer the questions from microprocessors यार. If you are able to, if you are a plus subscribed student, मेरा course तो एक बार attend करो, सारे questions you will be able to answer it. ठीक है, चलो. Next question. Not all the questions are from microprocessors. Don't worry. Other students, दो questions microprocessors का लाया, बाकी questions तो network और digital का ही है. So need not worry about it. Next question. When 8085 receives an interrupt from INTR, what happens? Yeah, please try. The program directly transferred to the fixed call location. 8085 waits till an interrupt acknowledgement is received and transfers program to a fixed location. The call location is determined by the external device. The program is transferred to the call location indicated by the HL register pair. I hope if you are able to have some basics of the microprocessor, you will be able to answer this question. It is given in 2009 DRDO question paper. Time हो गया भाई. ठीक है चलो. See here, INTR is non-vectored interrupt. INTR is a non-vectored interrupt. Non-vectored में क्या? Address is not fixed. So fixed call location, HL register pair में address है नहीं. External device देता है. Call location means the interrupt service routine का starting address. That is the vector address we call. That is given by the external device. ठीक है? चलो, let's move further. Next. Ready? Try this question. How many clock pulses are required to come back to its own position, the starting position? ये तो पिछले साल का है श्रुति. ओके, दैट इज फॉर लॉन्ग बैक. ओके, उस समय पे इट इज ऑब्जेक्टिव ओनली. Good. Last 10 questions, 10 seconds. Right. Okay. So you have a 4-bit serial input, parallel output, shift register is used with the feedback as shown. Okay. The shifting is QA, QB, QC, QD. Okay, it's a 4-bit shift register. QA, QB, QC, QD. Okay, the last QB and QD are connected with one exclusive OR gate or NOR gate. Okay. So assume if nothing specified initial condition तो सारे zeros assume करो भाई. So ये दोनों जीरो है ना, दोनों इक्वल है तो XNOR तो 1 देता है, बाकी तो शिफ्ट करो. देन अगेन दोनों इक्वल है तो 1, बाकी तो शिफ्ट कर सकते हैं। दोनों अलग अलग है ना 0, दोनों अलग अलग है ना 0, दोनों अलग, ये और ये अलग अलग है ना 0, ये दोनों अलग अलग है ना फिर भी 0। ठीक है, ये रिपीट कर रहा है कितना क्लॉक पल्सेस के बाद, 1 2 3 4 5 6। After 6 clock pulses, it repeats the same sequence. Okay, fine. It's not a ring counter, it's a linear feedback shift register with a feedback with the help of XNOR. Okay, right. Let's try. Let's try. Next question. So you can give a try here. So a synchronous U1 is the 4-bit synchronous counter with synchronous clear. Q0 is the LSB and Q3 is the MSB of the output. The circuit represents what? Mr. Mohammed, there is no trick to remember. Okay, every single student, it's quite natural, they will forget after some time. It's quite natural with me, you, any single student. So, all you need to do is revise as regularly as possible and practice the questions. Through practice, you can remember more. Don't worry to remember more. If you always think to remember, याद करना ऐसा सोच लिया तो there are more chances you can forget. अब just believe in your memory, you continue your preparation, first try always to learn not to remember, then automatically वो तो याद हो जाएगा, ये तो ऑटोमेटिक हो जाएगा। ओके, बचपन से जितना जितना कंडीशंस यू रिमेंबर एवरी सिंगल पर्सन का फेस, इतना फेसेस आप याद किया तो आपका मेमोरी का पावर ऐसा है। ठीक है, एटलीस्ट 1000-2000 faces you can see and recognize. Okay, then different type of people with their faces, with their voices, itna memory aapke paas hai. Okay, all these things happens because you never try to remember the things, but in exam and all those things you try to remember the things instead of understanding, there the problem occurs. Okay, chalo, here q3 is the MSP, right? q3, q2, q1, q0 start with all zeros. Okay, it is a 4-bit synchronous counter with the synchronous clear. So whenever you apply the clock, so clock 1 pe what happens? So firstly, when it is all zeros, what is connected here? Q2 bar and bubble cancels. When Q2 becomes 1, you will get the clear. So 0 0 0 0 0 0 1 2 3 and so on, 7 8 9 10 11 and 12. When 12 comes, it should give you clear, but it will not clear immediately because ये तो synchronous clear है. Synchronous clear तो आपको next clock pulse पे clear करते. So मेरा answer तो 13 पे it will be doing the clear. After 12, it will clear in the next clock. So the time you get the 13, it will become 0. So it is counting 0 to 12. Okay. So mod 13. अरे भाई mod 13 नहीं है क्या? क्या हुआ? 4-bit synchronous counter with the synchronous clear. Q0 is the LSB, Q3 is the Q2 is the MSB. Q2 है ना? अरे यार क्या हुआ? मैं तो गलत किया. Yes, whenever 4 comes, your Q2 should clear, but it will not clear in the same clock because it is synchronous. It will clear in the next clock pulse because it is synchronous. So it is a mod 0 to 4 तक it is counting. 0 1 2 3 4 पांच conditions count कर रहे हैं. 4 के बाद it is giving clear. So mod 5. If it is given synchronous clear, counter with synchronous clear. Okay, normal clear पे it is a mod 4 counter, but in synchronous clear है ना, इसलिए mod 5 counter. Next question. So the question here is find the output of PLD. अरे क्या हो रहा है? छोड़ दो. Read this. Find the output of the PLD. Last 2 seconds. हो गया टाइम. ये तो बहुत आसान है. How many of you able to do it? No answer by anybody. क्या हुआ भाई? So here, this is A bar, B bar, C bar. ठीक है. So what are the inputs connected here? C bar connect हो गया, B connect हो गया, A B C bar. From here, for this कुछ नहीं connected, 0. Here A bar और C. Okay, then here A B. So your output is 0. तो add करेंगे तो 0 या I mean you can neglect that. AB plus A bar C plus ABC bar. AB plus A bar C plus AB C bar. ठीक है. So this is your programmable logic devices का topic है. चलो next question पर. Okay, next question तो ready? So guys, try the questions and give your answers here. It can be right or wrong, doesn't matter. You just keep trying. Good. So a gate having two inputs and one output is implemented using 4 by 1 mux as shown. So, okay, what is that? So here you can see these two inputs are A and these two inputs are B. Okay. So for 0, 0, 0, 1, 1, 0, 1, 1. For 0, 0 and 0, 1, your inputs are A, B. Next, A, B. What is your output? A means 0, B means 1, A means 1, B means 0. So it is nothing but XOR gate ka truth table. Okay, it's a simple. You can do the by characteristic equation also. A bar B bar into I naught, A bar B into I1, A B bar into I2, A B into I3. ये सब कर सकते हैं. नहीं है तो very simple like this you can finish it off. Okay. Yes, very good. Who is that? Sai, right answer. चलो next question पर. Read. Next. Okay, in the logic expression, if A plus B bar C plus AC bar equal to 0 and 1 and this one. A plus AC bar can be written as A plus B bar C. Okay. C equal to A bar. So substitute C equal to C. A plus B bar C equal to 1. C equal to A bar. Then A plus A bar B bar equal to 1. That is nothing but A plus B bar equal to 1. Yeah, this is okay. A plus B bar. This if this is 1, firstly you know A plus AC bar is A plus C bar. So A plus sorry, A plus AC bar is A because if you take A common, 1 plus C bar is 1. So A plus this part is equal to 1. But C equal to A bar, if you substitute it, A plus A bar B bar is 1 because C is equal to A bar. From that, you can say A plus B bar equal to 1. Okay, good. Next question. Try this. Noise that is from the logic families. Right. Next, see here, your fan out formula FOH equal to IOH by IIH. So minus 400 milliampere by 20 milliampere, that will magnitude wise it is 20. Then what is the fan out low? IOL by IIL. Okay. So IOL is 8 milliampere by 0.36 milliampere magnitude. So 80 by 36, that will give me around 11 something. 200 by 9 is 22 something. So you should take minimum among the two, that is 20 is the answer. Okay. FO minimum of FOH and FOL is the fan out because the condition which satisfies both of them. Next, yeah, your favorite networks ka question. Give a try. It's not very difficult, easy question. Okay, done. So you can see just a simple source transformation can solve the. अरे क्या हुआ? आप कुछ नहीं करना, केवल एक सोर्स ट्रांसफॉर्मेशन अप्लाई करो, हो जाएगा काम. So one parallel with two, what is the answer? 2 volts in series with two. Two twos, 4 volts. Right. So what is the current here is 4 minus 2 by 5. 2 by 5. 0.4 is the answer. Okay. Very good. Next question. See, this exam can help. I mean, these kind of questions can give you an idea what kind of questions can be asked in any type of competitive exam. Okay, it is not only for one particular exam. The Norton's equivalent admittance with respect to the terminals A and B. With respect to YAB, you need to find the Norton's terminal, Norton's admittance. So please try. Okay. Replace the current source with the open circuit. Then this is a 2. This is I1. This is J1. Okay. Then you have a dependent source of 3I1 volts. That is the meaning. Now you apply here some voltage V. Assume some current I flowing. What is your ZTH is V by I ratio. Or admittance चाहिए तो 1 by V by ratio. Okay. So here don't take overall admittance equal to sum of individual admittances. ठीक है, because dependent source तो है. चलो, now ये I1 है तो ये कितना होता है सर? 2I1. So this is V. Can I say V is equal to 3I1 plus 2I1, 5I1? Okay. मेरे को V by ratio चाहिए. Fine, no problem. Now what is the current I? Current I is equal to, see here, this is I1 plus 2I1 by J. Okay, so I1 minus J2 I1 is I. Okay, so आपको I by V ratio will give you the admittance. I by V ratio क्या होता है सर? I1 minus J2 I1 by 5I1. I1 cancel करो, 1 minus J2 by 5. 1 by 5 minus J2 by 5. 1 by 5 is 0.2 minus J2 by 5 is 0.4. Option A. Option A is the right answer. Is this clear? Okay. Anybody have any query? Please tell me. I find the total voltage is equal to 3I1 plus 2I1, 5I1. हो गया एक part. And the current I is the assumed current to be flowing when you apply some external voltage V. This current I is equal to this current, that is I1 plus this voltage by impedance 2I1 by J1. Okay. Now I is equal to I1, J you take ऊपर ले लिया तो minus J2 I1 होता है भाई. So V by ratio निकालना चाहिए. Admittance चाहिए तो I by V ratio निकालना चाहिए. So I by V ratio क्या होता है? ये minus ये. I1 common लेके cancel करो. 1 minus J2 by 5, that is 1 by 5 minus J2 by 5, that is 0.2 minus J 0.4. Right. Let's go for the next question. Try this question. You need to find the current I. Right, try this. ये तो अभी किया almost I think not almost I think the same question. टाइम भी नहीं चाहिए यार, आसान क्वेश्चन है. किया क्या शिवम and कुना? ऑप्शन ये दिया. लेट मी चेक. सो अगेन सोर्स ट्रांसफॉर्मेशन का हिसाब से मोस्ट ऑफ द प्रॉब्लम्स ऐसा वाला सर्क्यूट्स में सोर्स ट्रांसफॉर्मेशन अप्लाई किया तो आपका काम आसान होता है. 5 into 0.5 into 2 1 2 now. So I. So 4 minus 1 by 6. 3 by 6, 0.5. Option A is 100% right answer. Next question. The figure shows the voltage source 20 volts and something. In the figure, the voltage source 20 volt source जो है ना वो तो deliver कर रहा है या absorb कर रहा है is the question. कौन सा एडवांस के लिए पुनीत? Right, give a try. Don't no idea here. This is for gate examination only. Option C, 100 watt. Okay, no issue. Mhm. Uh, Find Vx first. Vx minus 20 by 1, Vx by 10, 0.3 Vx equal to 0. Okay, that is the node analysis. Take the LCM 10 Vx minus 200 plus Vx minus 10.3 is 3 Vx equal to 0. So 11 Vx minus 3, 8 Vx equal to 200. आपका Vx कितना होता है भाई 25. ठीक है सर, Vx तो 25 है तो okay, current will flow from 25 to 20. So 25 minus 20 by 1, 5. So current तो 5 हो रहा है. So it will absorb the how much? Absorb 100 watts because the current is flowing from positive to negative. Okay, it will absorb that. सब तो सही नहीं लग रहा है. एक मिनट चेक करता हूँ. Vx 25. ओके, 0.3 Vx कितना होता है 25. 7.5 into 10, 750. Okay, it's good. It's fine. It's fine. Right? It is absorbing. Yes. Chalo, next question. Okay, the next question. Try. Fine. Fine. So the current I in the figure, दोनों तरफ 2 sin t, ठीक है. So this is 2 angle 0 degrees, 2 angle 0 degrees minus j, because omega equal to 1, plus j. So find this node voltage V. So V minus 2 by 1, V by 1, V by j, plus V minus 2 by minus j. V minus 2 by 1, V by 1, V by j, V minus 2 by minus j equal to 0. So V minus 2 plus V minus jV plus jV. Okay, minus into minus plus. Equal to 0. So आपका V क्या होता है सर? आपका V कॉमन ले लो. V plus V, 2V, minus JV plus JV cancels, equal to 2 minus J. V equal to 1 minus J. Current I equal to V by 1, that is 1 minus J. So I equal to real axis positive, imaginary axis negative, minus theta na, root 2 angle minus 45 degrees. Okay, if you need to convert, it will be root 2 sin t minus 45 degrees. Because you have taken maximum, you should assume it as a maximum. Option B. Okay. Okay. What's happening here? You people are committing the mistakes continuously. मैं तो गलत नहीं किया ना. Next. Another question. Try this. For the circuit shown in the figure, in order to obtain maximum power transfer, the value of the load impedance must be how much? For maximum power transfer, the load impedance must be complex conjugate of the source impedance. Using that concept, give it a try. Okay, so please try and tell your answer. Okay, can you show the solution of the previous? Yeah, you can see V minus 2 by 1, V by 1, V by J, 1, V minus 2 by minus J. V minus 2 plus V minus JV plus JV minus J2. Minus J2 ये माइनस माइनस कैंसिल हो जाएगा, माइनस J2 होता है ना. माइनस माइनस V by J minus J2 यार. 2 plus J2, 1 plus J, 1 plus J, plus. I'm sorry. A is the right answer. Okay, previous one A is the right answer. साई कैलकुलेशन का गलत किया. ठीक है, इस केस में क्या होता है सर? इफ यू रिप्लेस द वोल्टेज सोर्स विद a short circuit, then you have 1 minus J1, this is J1 and 1. What is your ZL? ZTH. It is 1 plus J1 parallel with 1 minus J1. 1 plus J1 into right. So this will be 1 plus J1. J1 cancels. 1 plus J1. J square equal to minus into minus plus 2 plus J. So for maximum power transfer, my ZL must be complex conjugate of ZTH. So 2 minus J1. So the load impedance must be complex conjugate of the source impedance. It must be 2 minus J. Okay, very good. So last 5 minutes. Yesterday we have already done this model, right? So no need to do the same question again. Read this question, easiest question. Thank you, Dhananjay. Thank you very much. All the best here. I'm very happy to see you are placed in MediaTek. Okay. So thank you. Thank you so much. All the best. Okay. Keep working hard and achieve many more. Where are you last time? Where you are from? Jabalpur. Okay. Nice. Hi, Akshat. Next, see here, this is the easiest question. Which of the following theorem applicable for both linear, non-linear circuits? Okay, so superposition, linear, Thevenin's, Norton's, everything is linear only. Okay, next question. Okay, last question for today's class. Last question. Okay, great. Thank you. So, where is your working place now? Pata nahi, Akshat. When is your joining? Dhananjay? Oh, okay, fine. We'll meet when I come to Bangalore. We'll meet. Sure. Okay. I hope you have my number anyway. You can stay in touch with me. So in the circuit shown below, switch S1, S2 are in open, okay, and close position respectively, okay. सो S1 तो ओपन पे है, S2 तो क्लोज हो गया. ओके, एट टाइम t इक्वल टू फॉर ए लॉन्ग टाइम. सो लॉन्ग टाइम तक ये मेरा पोजीशन है 10, ये तो 10 के, ये भी 10 के, ये तो 5 के. S1 तो क्लोज किया, कैपेसिटर तो ओपन. ओके, स्टडी स्टेट है ना, ये तो 10 के and S2 is also open. S1 is closed, S2 is open. As long as S2 is open, there will not be any current flow in this network, in this branch. Okay, there will not be any current flow. This is a 5 volt source. Okay, so you can neglect that and you can get here 5 volts. This is the 5 volts. Just time t equal to t naught के थोड़ा सा पहले, just before the switching action, ये वाला condition है t naught के पहले. So T naught, so immediately after the transition of the switch, so at T equal to T naught plus, क्या किया examiner ने, 1 minute, S1, S2 are in open and close. So S2 close पे है, S1 open पे. No issue. So here, this is the open circuit. So this will be with this polarity you will be getting 5, right? At time t equal to t naught plus, S1 open किया, S1 तो open, this is of no use, and S1 is closed now. This is 10k, 5k, this is another 10k, 10 volts, and capacitor is open circuited. S2 is closed, S2 is opened, leave that part. Okay, but capacitor will be having some initial voltage. How much? Capacitor का initial voltage कितना? 5 volts है ना? So this 5 will be present. Now what is the current through the 5k? You need to find this current. Okay. Take this node voltage V minus 10 by 10, V by 10, V plus 5 by 5 equal to 0. Take the LCM, V minus 10 plus V plus 2V plus 10 equal to 0. आपका V कितना आता है सर? 0. So this node voltage is 0. So this current will be 10 minus 0 by 10, 1 ampere. Okay. There will not be any current flow here. The same current will come here. So it will be 1 milliampere. Okay. Because it is 10k now. So I'll repeat if you want. See here, at time t equal to just before the switching action, what happens is the switch S1 is open, S2 is closed, the capacitor is charged to the 5 volts, negative. Okay, that minus 5 volts. Then after that the switch, this one will be opened, closed, and this one will be opened. So capacitor acts for sudden change at time t equal to 0 plus, capacitor acts as initial voltage in series with a short circuit. ठीक है, सो कैपेसिटर का वोल्टेज है और शॉर्ट सर्क्यूट है. हियर इतना कितना वोल्टेज है यहीं पे 5. सो 5 लगा दिया, मैं नोड वोल्टेज निकाला. नोड वोल्टेज कितना आया? V minus 10 by 10, V by 10 and V minus 5 by V plus 5 by 5 will give V plus 5 by total resistance 5 will give you V equal to 0. So V 0 है ना, this voltage minus 0 by 10k will give you ये वाला करंट. ये 0 है ना, इसमें कुछ करंट नहीं जाएगा, V by 10, and the same current will flow here and the total current will be 1 milliampere. Okay, is it okay now? Okay, fine. That's all for today, guys, from my side. Okay, Shivam, you can see the polarity of the capacitor voltage. Ulta kiya na maine. So before the price clear, subscribe to Unacademy using the code Shankar10. You will be getting the maximum discount. अभी तो offer भी चल रहा है 20% unlock 20 का. So if you want to take the subscription, you can take it and start from tomorrow with the general aptitude started. Going to start by Anil Sharma sir. Okay. So thank you very much for your time, guys. Tomorrow you don't have any class. I'll update you further when I am going to take the class. Okay. Dhananjay, I have already shared the number. You can see. Not an issue. Okay. Thank you very much, guys. Good night. See you all. I'll update you the next class details soon. Okay. Bye bye. Good night.